For this lesson, we're going to discuss evaluating an expression. So what that means is, if we have something as simple as, let's say, 2x plus 10, what does it mean if we take x equals 5 and put that in place of x? So we can say that as we're going to plug 5 into x. So you take your expression, open up a set of parentheses, place in 5, and then simplify this down to a single number. So 2 times 5 is 10, and 10 plus 10 is 20. There was nothing special about using x equals 5. I could have picked any number. So let's just try this again for a different value, like x is equal to negative 0.5. Same idea. You would take your expression. In place of x, you'd put negative 0.5, and then simplify this. So let's see, 2 times 0.5 is 1. That's a negative 1 plus 10 is equal to 9. And this is it. To evaluate an expression, you take a given number, put it in place of a given variable, just being careful to use parentheses. So in our first example, we're just going to look at a couple that are a little bit more complicated, but it works the exact same way. For part A, we want to take y is equal to 2 and put that in place of, or plug in place of the y and the y squared. So I'll take negative 1/3. In place of y, I'm going to write this as negative 2 over 1, since we have to combine two fractions together. And then I'll put plus, okay, again for y squared, I don't think we need a fraction this time, so I'll just put negative 2 and I will square it. So here we've plugged the number in. We just have to now simplify it down to one value. So for the first term, negative 1/3 times a negative 2 over 1, it's going to be positive. Nothing cancels between the numerator and the denominator, so this is just a positive, and I'll write 2 over 3. So next, we are squaring a negative 2, so that's going to become positive, and 2 squared is 2 times 2, or 4. And you could, I guess, just write the answer as 4 2/3 if you want to leave it as a mixed number. But you could also write this as an improper fraction. That would be 4 times 3 is 12, and 2 more is 14. So this is also 14/3. And all right, let's look at part B. So same idea. In this case, in the place of every x, I'm going to put negative 1. So let's try that. We have 1 minus, okay, that's negative 1 squared over 2 plus negative 1 to the 4th over 24. So however many x's appear, it's the same number that's going in place of it. So there are just 2 here, which is why there's a negative 1 appearing twice. Let's see, to simplify this, if I deal with the exponents first, that's going to be 1 minus, if we square a negative 1, that's a positive 1. And if you raise it to a 4th power, it's going to be positive as well. So that's a positive 1 out of 24. Okay, we need a common denominator, and I think 24 is going to work for each of these fractions. And let's see. For the very first fraction, we're multiplying by 24, so 24 over 24 is the same thing as 1. For the second fraction, we're multiplying by 12, so 12 over 24 and 1/2 are the same. And I didn't do a thing to the last fraction, so that's just still 1 over 24. I think we can do this in one step. It's going to be something out of 24, and what I'm thinking of is, okay, it's a 24 minus a 12 plus 1. That's going to be what's left over in the numerator. So 24 minus 12 is 12, and then 1 more is 13, and that's out of a total of 24. So the idea of evaluating the expression is not difficult. It's just put that number in place of the variable. What might take more time is potentially simplifying the number, but that's it for this example. All right, so for the last example here, example 2, kind of like scanning through this problem, I'm giving us an equation this time. So it's not just an expression, but I'm saying that there's an expression equaling to A. What this is going to represent is if you have a circle of some given radius, r, if you know the length of r, you can apply the formula A is equal to pi r squared to figure out how much space this takes up. And for pi, I'm going to use the approximation 3.14. So for the rest of this example, I'm going to say the area is equal to 3.14, and that's going to be multiplied by r squared. So we'll use this. This is technically an approximation, but it is good enough. So this formula tells you the area of a circle if you only know its radius. And so for this example, I'm saying if we have a circle whose radius is a total of 4 feet, how much area does this circle take up? And the good news is the idea is simple. You would take 4 feet and you'd put that in place of the radius and then just simplify it, and that tells you the area. So let's write that out. The area is 3.14. I'll open up some parentheses. I'll put in 4. If I'm going to actually add something extra here, technically it's 4 feet, so I'm just going to write the unit of measurement with this as well. So 4 feet squared. The last thing to do is just now take this and simplify it down to a single number. So let's see. 3.14 we'll deal with last, but we're squaring 4, and 4 squared is 16. This is 3.14. If you square 4, you get 16. But I'm going to include one other thing here. You're not only squaring 4, you're also squaring the unit of measurement. So that's saying feet times feet, and that's often just called square feet. So I squared 4, I squared feet, I got 16, and I got square feet. So the last part of this is to multiply 16 and 3.14. All right, and for that, I get 50.24. You could just do that right on a calculator. You don't have to do that by hand, but 50.24 square feet. So maybe just like really quick here, the idea of square feet is, okay, feet is a distance. So like maybe this is 1 foot. If you want area, which should be some type of space that you're occupying, if I were to go 1 foot at a 90-degree angle from the first one, this traces out a square. And we call this square 1 square foot. So to interpret this number, sure, we just multiplied 3.14 and 16 and got 50.24, but you're saying you have 50.24 of these things over here. So it's nice that this formula not only works for the numbers, but it works for the unit of measurement too. It took a distance, which was just feet, and it converted it to square feet to say that we have 50.24 of these squares. So that's just the first part of this question, but I actually included something else here as well. Okay, if the radius is doubled, by what factor does the area of the circle increase? So what this is getting at is, if we took this original circle, and let's say it wasn't 4 feet, but we increased the radius to 8 feet. So I'll write that over here. We'll say, well, what if the radius is now 8 feet? That doubled the radius. The area has to increase too. I don't know, does it double the area? Is it going to be more than double, like less? Like what's going to go on here? To figure out this question, here's what I'm going to do. I'm going to go back to my formula. And in place of the radius, I'm going to enter 8 feet. And I just want to see what number we end up with. So the area is, it's 3.14. If you square 8, you get 64. And if you, again, square the feet, you get square feet. If I multiply 3.14 and 64 together, we get 200.96 with square feet at the end. So we doubled the radius. We started it with an area of 50.24. That actually more than doubled the area. I mean, look at this. If we only doubled the area, it would only be over 100, but this looks like it's, I don't know, maybe 4 times as big. I want to just verify that. So here off to the side, we started with 50.24 square feet. If I multiply that by 4, does that take me to my new number, which is 200.96 square feet? And I checked that in a calculator, and that is for sure true. So it's kind of interesting. If you start with your radius of 4 and you double this to a radius of 8, well, the area, here we multiplied by 2, the area went from 50.24 down to an area of 200.96. So this actually quadrupled and did not double. And the reason for that is we had this squared exponent. If you double something and square it, it's actually contributing a factor of 4 into your expression. So there's a lot happening in this one example, but the basic underlying idea that I want to make sure is okay is if you have an expression, do you understand what it means to plug something into the variable? And it's as simple as open up the parentheses, place in the number, and then perform the given operation. What's kind of new here is this idea of dealing with the unit of measurement, but that is all for this example.